Ever wish you could like instantly pull all the important facts and figures from a huge stack of PDF reports?
Oh, yeah, for sure.
Well, today we're diving into how to do just that,
Okay.
using Python to unlock the data trapped inside those PDFs.
It really is like having a key to a treasure chest, isn't it?
Yeah,
Think about all those reports
I
and all
know.
that research papers, invoices.
Yeah.
They're packed with potential insights just waiting to be analyzed.
Absolutely. And our guide for this deep dive is a 2024 article from World Insider,
Okay.
which does a fantastic job of breaking down the tools and techniques you can
All
use.
right. Uh-huh.
It even touches on some future trends, which is always exciting.
I think what's really important for you to take away from this deep dive
Yeah.
is that you don't need to be a Python expert
Okay.
to start benefiting from this.
Right.
Even a basic understanding of PDF data extraction with Python can open up a lot of possibilities, no matter what your technical skill level is.
So the article starts off strong, making a case for why Python is so good at this. Why is Python the tool for this job?
Well, one big reason is its flexibility.
Okay.
You know how frustrating it is when PDFs aren't standardized?
Uh-huh.
Luckily, Python handles a wide range of PDF formats and versions.
Right, and it can also process large volumes of PDFs quickly.
Exactly.
That seems crucial when you're dealing with a lot of data.
Yeah,
Time is of the essence.
definitely. And of course, there's the fact that Python is open source,
Right.
meaning it's free.
Right.
You don't need to shell out for expensive software to get started.
Now, before we get into the specific Python libraries you can use,
Yeah.
the article does something really smart.
Okay.
Takes a step back to explain the basic anatomy of a PDF document.
Understanding the basic structure of a PDF is a bit like knowing the blueprint of a building before you start renovating.
Duh.
Knowing about the header,
Mm-hmm.
body cross-reference table, and trailer will help you grasp how different Python libraries interact with these elements.
Hold on, a cross-reference table.
Yeah.
For those of us who aren't PDF anatomy experts,
Right.
can you quickly break that down?
Sure. Think of it as a roadmap
Okay.
that tells the PDF reader where to find specific objects within the file,
Mm-hmm.
like pieces of text or images.
So it's essentially helping the software find its way around the PDF.
Exactly.
Okay.
And different Python libraries work with this roadmap in different ways,
Okay.
which you'll learn more about as you dive deeper.
Now, I know extracting data from PDFs isn't always straightforward.
Right.
What are some of the challenges people run into?
One of the biggest challenges is dealing with complex layouts,
Mhm.
PDFs that are designed for visual appeal, with things like multi-column text
Okay.
sidebars, headers, and footers.
Yeah.
They can make data extraction really tricky.
So it's not always as simple as just grabbing the text from the page.
Another common challenge is dealing with PDFs that are image-based.
Okay.
Scanned documents or PDFs where the text is actually part of an image.
Yeah.
Those require a special approach.
And what about those PDFs that are encrypted
Yeah.
or password protected?
Those are challenges too.
Yeah.
Some are easy to work around,
Wow.
while others need a bit more finesse, like
All right.
providing authentication.
It sounds like there's a lot to consider when choosing the right tool for the job.
Yeah.
So which Python libraries are essential for tackling these data extraction challenges?
Well, the article gives a great overview of some of the most popular ones.
Okay.
If you're just starting out,
Mm-hmm.
PyPDF-2 is great for beginners and basic tasks.
And if you need more control
Yeah,
and are comfortable with a bit more complexity,
right.
the article suggests pdfminer.6.
Exactly.
Okay.
Now, if you're frequently dealing with tables in your PDFs,
Right?
you'll want to have Tabula Pi and Camelot in your toolkit.
Why? Two different libraries for tables. Aren't tables pretty straightforward?
Not always.
Okay.
Tabula Pi is great for simple tables,
Mm.
but Camelot is a bit more powerful
Wow.
and often provides better results when you're working with really complex tables,
Okay.
like those with merged cells or spanning rows.
That makes sense.
Yeah.
Is there a one-size-fits-all solution, a library that can do it all?
Well, the article highlights PDF Plumber as a solid all-in-one solution.
Okay.
Think of it as a Swiss Army knife for PDF data extraction.
Okay.
It brings together the capabilities of several PDF tools.
Okay. So we've got an idea of the challenges
Yeah.
and some of the key libraries.
Mm-hmm.
Now let's get into the nitty-gritty.
Okay.
How do you actually go about extracting text from a PDF using Python?
Well, the article does a great job of walking you through the process with code examples so you can see exactly how it works. You'll find examples using both PyPDF2 and PDFminer.6, which gives you a good sense of how different libraries approach the task.
Okay, but just hearing PyPDF2 and PDFminer.6 doesn't tell me much. Can you give me a sense of when I would choose one over the other for extracting text?
Absolutely. PyPDF2 is like your trusty everyday tool. It's straightforward and efficient for simple extraction tasks. But if you're working with a PDF that has a more intricate layout and you need finer control over the extraction process, PDFminer.6 is your go-to. Think of it as a precision instrument for those more complex jobs.
So if I'm working with a document that has multiple columns, lots of visuals, or a unique structure, PDFminer.6 might be a better bet.
Exactly. Plus, PDFminer.6 is great for extracting metadata, which can be really valuable if you need to organize or search a large collection of PDFs. It's like having a librarian for your PDFs.
Okay, that makes sense.
Yeah.
Now, you mentioned earlier that TabulaPy and Camelot are both good for extracting tables, but they each have strengths and weaknesses. Can you elaborate on that?
Sure, TabulaPy is like your quick and easy solution for tables. Its API is really straightforward. You basically point it to the PDF, tell it which pages to look at, and it does a decent job with most simple tables. But if you're dealing with a table that has merged cells spanning rows or other tricky formattings, Camelot is likely to give you more accurate results.
So for those really complex tables, Camelot's advanced algorithms are better at handling those tricky situations.
Right, and it's interesting to note that under the hood, these libraries work in different ways. TabulaPy actually relies on a Java library behind the scenes, while Camelot is pure Python.
That is interesting. Okay, so we've talked about text and tables.
Yeah.
What about those pesky image-based PDFs? How do you extract data from those?
That's where OCR, optical character recognition, comes in. The article introduces a powerful OCR engine called Tesseract, which you can access through Python using a library called PyTesseract. It's like having a pair of superpowered reading glasses for your computer, allowing it to decode text from images.
The article even provides some tips for making sure the OCR process is as accurate as possible, right?
Yes. Things like pre-processing the images to enhance contrast and remove noise, which can really improve accuracy. And remember, if you come across an encrypted PDF, you can often use PyPDF2 to handle that, as long as you have the password.
That's good to know. Now, once you've extracted all this data from a PDF, it's not very useful if it's just a jumbled mess. You need to organize it right.
Absolutely. The article stresses the importance of structuring the extracted data so you can actually analyze it. Techniques like regular expressions and natural language processing can help you parse the text and organize it into a usable format. And for those tables you extracted, you can convert them into pandas data frames, which are like super-powered spreadsheets within Python, perfect for analysis and manipulation.
And then, of course, you might want to export that nicely organized data. What are some of the options for doing that?
The article covers common formats like CSV, JSON, and Excel, so you can easily share your insights or use the data in other applications. Now, so far, we've been talking about extracting data from single PDFs. But what if you have hundreds or even thousands of PDFs to process? That sounds like a nightmare scenario.
That's where automation comes in. And Python is perfect for that. The article walks you through how to create Python scripts for batch processing, which essentially means handling multiple PDFs automatically.
All right.
It's a huge time saver and lets you focus on the analysis rather than the tedious task of manual extraction.
Exactly. And the article goes beyond just outlining the steps. It emphasizes the importance of incorporating error handling and logging into your scripts. That way, if there's a problem with a particular PDF, your script won't crash. It'll just log the error and move on to the next file.
It sounds like a lifesaver when you're working with large data sets where things can go wrong unexpectedly.
And to take automation to the next level, the article even mentions tools like cron and Windows Task Scheduler, which allow you to schedule your extractions. So you can set it up to run automatically at certain times, like overnight, and wake up to your data all ready to go.
Now, shifting gears a bit, let's talk about best practices. Are there any general tips or strategies people should keep in mind for successful PDF data extraction?
Definitely. The article has a whole section on this. One key tip is to process the PDF in smaller chunks. Trying to load an entire massive PDF into memory at once can slow things down, so breaking it down into smaller, more manageable pieces can really improve performance.
That's a great tip, especially for those working with large or complex PDFs. Anything else?
Well, another suggestion is to leverage the power of multiprocessing, which essentially lets you run your extraction tasks in parallel. Think of it like having a team of workers tackling different parts of the job simultaneously. It can significantly speed up the process, especially if you have a multi-core processor. And of course, always remember to validate your data. There's no point in extracting a bunch of information if it's not accurate.
That's a great reminder. So how do you go about validating data you've extracted from a PDF?
There are a few different approaches. You could cross-check your data against expected formats, ranges, or patterns, or you might compare it to other reliable sources or databases. The goal is to ensure that the data you're working with is as accurate as possible.
Okay, so we've covered the technical side of PDF data extraction pretty thoroughly. But I'm curious to hear about some real-world applications. How are people actually using these techniques in different fields?
The article provides some great case studies that highlight the practical applications of these techniques. For example, it describes how a major investment firm used Python to automate the analysis of quarterly earnings reports from hundreds of companies.
Wow, that sounds like a game changer. I can only imagine how much time and effort that saved them.
Exactly. They were able to extract key financial metrics, things like revenue net income and debt ratios, which allowed their analysts to focus on interpreting the data and making informed decisions rather than spending hours or even days manually pulling it from PDFs.
That makes perfect sense. What are some other examples?
Well, the article also describes how a physics research group used Python to extract experimental results from hundreds of scientific papers.
That's fascinating. I bet that opened up new avenues of research for them.
It did. They were able to build a comprehensive data set that allowed them to analyze trends and gain new insights that wouldn't have been possible without automating the data extraction process. And for businesses looking to streamline their operations, the article highlights how Python can be used to automate invoice processing. One case study describes a manufacturing company that implemented a Python-based system to extract data from PDF invoices, which significantly reduced their processing time and minimized data entry errors.
And it's not just about efficiency. It also reduces the potential for human error, which can be costly.
Right. And finally, the article touches on how Python can be used for content management and document archiving. A law firm used Python to create a searchable archive of thousands of case documents. Think about how valuable it would be to instantly search through those documents for specific keywords or phrases rather than manually sifting through pages and pages of text.
It sounds incredibly useful. But let's be realistic. PDF data extraction isn't always a walk in the park. We know that real-world PDFs can be messy and unpredictable. What are some common issues people encounter, and how can they troubleshoot them?
You're right. The article dedicates a section to troubleshooting, which is really helpful. One of the biggest headaches is dealing with poorly formatted PDFs.
So PDFs that are just a mess structurally, what can you do about that?
Sometimes you can try to pre-process those PDFs using tools like Adobe Acrobat to clean up the structure, or maybe even convert the PDF to a more manageable format like HTML.
And if that doesn't work?
Well, sometimes you just have to roll up your sleeves and get a bit more creative. You might need to implement some custom parsing logic, perhaps using regular expressions to identify and extract the data despite the inconsistencies.
So it's like learning how to be a PDF detective.
Exactly. Another common issue is handling non-standard fonts and characters, which can really throw off the extraction process. The article suggests techniques like font mapping, where you create a dictionary that maps non-standard fonts to their standard equivalents. Or you can use a library like Font Tools to analyze the PDF and determine which fonts are being used.
That sounds like a deep dive into the world of fonts. Are there any other common pitfalls or errors people should be aware of?
Well, each PDF extraction library has its own quirks and potential issues.
Ah, yes. The joys of working with different software tools?
The good news is the article provides a handy table that summarizes common library-specific errors and suggests quick fixes. It's like having a cheat sheet for those, oh no, what went wrong moments.
That's incredibly useful.
Yeah.
Speaking of libraries, the article does a really good job of comparing some of the most popular tools like PyPDF2 versus PDFminer.6 and TabulaPy versus Camelot.
Right. It lays out their strengths and weaknesses side by side, which can be really helpful in deciding which tool is right for a specific project. And it emphasizes that the best choice often depends on the complexity of the PDFs you're working with and the specific data you need to extract.
Now, I'm intrigued by this section on advanced topics that the article mentions. What sorts of advanced techniques are we talking about here?
This is where things get really interesting. The article touches on regular expressions, machine learning, and even cloud-based PDF processing services. Regular expressions, or regex, as they're often called, are incredibly powerful tools for pattern-based extraction.
I've heard about regular expressions, but they always sound a bit intimidating. What's a simple way to think about them?
Think of them like super-powered search functions that can pinpoint very specific pieces of data within the text you've extracted. You can use them to find things like phone numbers, email addresses, or even product codes buried within a PDF.
Okay, that's a helpful way to think about it. And what about machine learning? How is that being applied to PDF data extraction?
Machine learning is transforming this entire field. The article gives examples of how it's being used for layout analysis, content classification, handwriting recognition, and even named entity recognition, where you can automatically identify and extract things like names, dates, and locations. It's pretty amazing.
So machine learning is essentially helping us go beyond basic extraction and start to really understand the meaning and context within a PDF.
Exactly. And if you're dealing with massive PDF data extraction tasks, cloud-based services like Amazon TextRact, Google Cloud Vision API, and Adobe PDF Services API can offer the scalability and advanced features you need.
Those sound like heavy-duty solutions for serious data extraction challenges.
They are. These services typically provide APIs that you can integrate into your Python scripts. So you can send your PDFs to the cloud for processing and get back the structured data without having to build all the infrastructure yourself.
Okay, so before we wrap up our deep dive into this World Insider article, I'm curious to get your take on the future of PDF data extraction.
Right.
The article mentions some emerging trends that sound pretty exciting.
Yes, there's a lot happening in this space. The article highlights advancements in OCR technology, the growing integration of natural language processing, and the emergence of new Python libraries for handling PDFs. It's clear that this field is continuing to evolve at a rapid pace.
Can you give me an example of something that particularly excites you about the future of this field?
Well, the advancements in AI-powered OCR are really impressive. They're making significant strides in accuracy, especially when it comes to recognizing handwritten text and dealing with complex layouts. We're also seeing the development of real-time OCR capabilities, which means we'll soon be able to extract data from PDFs almost instantaneously.
Wow, that's amazing. And what about natural language processing? How is that changing the game?
With NLP, we're not just extracting text, we're starting to understand the meaning and context within that text. This means we can do things like sentiment analysis, identify key entities and relationships, and even generate summaries and reports automatically from PDFs. It's taking data extraction to a whole new level of sophistication.
It's fascinating how these technologies are converging to make PDF data extraction more powerful and insightful than ever before.
And the Python ecosystem is constantly evolving, with new libraries emerging to push the boundaries of what's possible. The article mentions a few to keep an eye on: PyMa PDF, PDF2 image, PyTF Borb, and even a new version of PyPDF called PyPDF4.
So even though we've covered a lot of ground in this deep dive, it sounds like this is just the beginning of a much larger journey into the world of PDF data extraction.
That's a great way to put it. I think the key takeaway from this article is that PDF data extraction is a process of continuous learning and exploration. There's no single right way to do it. It's about finding the tools and techniques that work best for you and your specific needs.
Right. And as we've discussed, there are a lot of great resources available to help you along the way.
Absolutely. The Python community is incredibly supportive, and there are tons of tutorials, forums, and online communities where you can connect with others, ask questions, and share your experiences.
That's great advice. Well, I think we've thoroughly explored the world of PDF data extraction using Python.
We've covered a lot of ground, from the basics to more advanced topics, and we've even tackled some of the most common challenges and questions people have.
Hopefully our listeners now feel equipped to start their own data extraction journeys.
Absolutely. Remember, the key is to start experimenting, exploring the different libraries and techniques, and finding what works best for you.
So to all our listeners out there, are you ready to unlock the valuable information hidden within your PDFs?
We hope this deep dive has empowered you to do just that.
That's all for this episode of The Deep Dive. We'll see you next time.
All right, we're back and ready to tackle those frequently asked questions about PDF data extraction.
I'm glad we took that break. I think going through a few of these FAQs will be really helpful for anyone who's new to this whole process. The article does a great job of addressing the most common questions people have. So let's start with a really basic one. One of the first questions in the FAQ is, how do I even begin? How do I read and scrape data from a PDF using Python?
It's a great starting point because it addresses the fundamental question of how to approach this task. And the answer, as we've been discussing, is to use a Python library specifically designed for PDF extraction.
An article provides a quick example using PyPDF2 to extract text from a PDF, which is a good illustration of how simple it can be for basic tasks.
Right. But it also emphasizes that for more complex PDFs, especially those with tables, you'll likely want to use more specialized libraries like TabulaPy or Camelot.
Now, this next question caught my eye. It asks, can GPT-4 analyze PDFs? That seems like a powerful combination.
It does, doesn't it? But it's important to understand that while GPT-4 is incredible at what it does, it can't directly read PDF files.
So it's not like you can just feed a PDF into GPT-4 and expect it to magically spit out insights.
Exactly. GPT-4 needs text as input. So the trick is to first extract the text from the PDF using one of the Python libraries we've discussed. Then you can feed that extracted text into GPT-4.
And that's when things get really interesting. The article gives examples of how you can use GPT-4 to summarize the extracted text, answer questions about the content, even translate it into different languages. You
Mm.
can even have GPT-4 generate different creative text formats based on the PDF content.
It's a perfect example of how you can combine the strengths of different tools to create a really powerful workflow.
Now, there's a question here about extracting structured data from unstructured data. Can you explain what that even means in the context of PDFs?
Sure. Even though a PDF might look visually structured, with headings, paragraphs, and tables, the underlying data is often just a stream of text and images. It's not organized in a way that a computer can easily understand.
So how do you bridge that gap and transform that unstructured data into something more meaningful and analyzable?
That's the real challenge. And the article outlines several techniques you can use. Things like regular expressions for pattern matching, named entity recognition for identifying specific elements, template matching, even machine learning models. The choice really depends on the complexity of the PDF and the specific information you're trying to extract.
Now, this next question is one I see popping up a lot online. Someone wants to know which library is better, PyPDF or PyPDF2.
The article is very clear on this one. PyPDF2 is the way to go. It's more actively developed, has a wider range of features, and is generally considered more robust and reliable. There's even a newer library called PyPDF4, which is essentially an improved version of PyPDF2.
So for those just starting out, stick with PyPDF2 or PyPDF4. Got it. Now, what about extracting data from PDF forms that have been filled out? That seems like a common task.
It is a common task, and you're in luck. Libraries like PyPDF2 or PDFreader can help you with that. You can access the form fields and extract the values that have been entered. The article even provides a code example to show you how to do this using PyPDF2.
So whether you're dealing with simple text fields or more complex checkboxes and radio buttons, there are tools available to extract that information.
Exactly. And here's another question that I think a lot of people have. It's about converting a PDF into a structured data set.
Ah, yes. Turning that mess of text and images into something that's organized and ready for analysis.
The article points out that it's a multi-step process. First, you extract the raw text, then analyze it to identify patterns and structure. Then you parse that text into meaningful elements. And finally, you organize those elements into a format like a dictionary, a list, or a pandas data frame.
So it's not a simple one-click solution.
Not usually, but the article provides a basic example to get you started and highlights the importance of understanding the structure of the PDF you're working with.
Now, we've talked a lot about automation, and the article has a whole FAQ section dedicated to that. Can you give us an overview of what's covered there?
Sure. The article breaks down how to automate your PDF data extraction workflows step by step. It covers creating a script that can handle multiple PDFs, scheduling that script to run automatically, and implementing error handling and logging so you can catch any issues and keep the process running smoothly. It even touches on using multiprocessing to speed things up.
It sounds like a comprehensive guide to setting up an efficient and robust PDF data extraction system.
It really is. And the last question I wanted to highlight is about finding the best way to extract data from a PDF.
Ah, yes, the million-dollar question. Is there a single magical solution that works for every PDF?
Unfortunately, no. The best approach really depends on the structure of the PDF, the type of data you need, and your comfort level with different libraries and techniques. But the article does offer some solid recommendations. For text-based PDFs, PyPDF2 or PDFminer.6 are good choices. For tabular data, try TabulaPy or Camelot. For scanned PDFs, you'll need to incorporate OCR, and for complex layouts, a combination of different techniques might be necessary.
So the key is to understand the tools available and choose the ones that best suit your needs.
Exactly. And remember, the Python community is a fantastic resource. Don't hesitate to reach out to online communities or forums if you get stuck or have questions.
That's great advice. Well, I think we've thoroughly explored this world of PDF data extraction using Python. Really fascinating stuff.
It is, yeah. A lot of really cool tools and techniques to unlock those insights hiding in our PDFs.
Absolutely. To wrap things up, if you're interested in learning more about this, be sure to check out that 2024 World Insider article. We'll include a link in the show notes.
Definitely worth a read.
All right, that's all for this deep dive. See you next time.